Okay, let us start with HCF word problems. And before we dive into solving questions, I would like you to note down these key points to remember so that it becomes easier to differentiate between LCM and HCF word problems, because many times it's hard to um, decide which one to apply, because the question is constructed in such a way that it makes it really confusing. So if you remember these keywords, it will be a lot easier for you to solve. So the thing is, use HCF when you see, means highest common factor, when you see the word maximum, greatest, largest, these in your question, or a question that says dividing into groups or arranging into rows or columns, cutting into pieces, or to fit something into something else. So when you see these kind of keywords in the question, it means you need to apply HCF. So I'm not elaborating every word here, though I will be solving questions, and from the solution we'll be understanding what these keywords are meant for. So let's start with solving questions. So here is a question. It says you have 12 apples and 18 oranges. You want to make fruit baskets with the same number of fruits in each, and each basket must contain only one type of fruit. What is the largest number of fruits you can put in each basket? So here we have two different types of fruits, apples and oranges, and you want to put them into baskets. And the condition here is that in each basket there must be equal number of fruits, and also in each basket there should be only one type of fruit containing only apples or oranges. So the answer is, and you'll have to find the number of baskets, sorry, number, what is the largest number of fruits you can put in each basket. So that is given by the HCF of 12 and 18. If you remember the keywords here, so you can see the word largest is used here, and also you are putting something into something else or dividing the given items. So considering all those keywords, this particular question suggests that we must use HCF. Now HCF of 12 and 18 is 6. You prime factorize them individually and check, it is 6. While other other common factors of HCF, other common factors of 12 and 18 are 2, 2 divides both of them, 3 divides both of them, and 1 is always there. Okay, 2, 3, and 6. So out of these three, 6 is the highest common divider or the highest common factor. So that means in each basket there must be 6 apples or oranges. In that way, you can equally divide them in the largest possible ways. That means when you look at the number of apples, we have 12. So this can be divided into two baskets, 6 and 6. When you have 18 oranges, this can be divided into 3 baskets. So questions can be, they can further add the question by saying how many baskets are required when you divide them in this manner. So there will be 5 baskets. So in this case, that was not asked. So we only had to find how many fruits one basket contains. When we divide them in the largest possible manner, that is 6 fruits. So answer is one basket should contain 6 fruits. So doing so, what happens is you will be putting in the largest number of fruits. If you had chosen 2 or 3, then suppose, okay, if you had chosen 3, for instance, you could have chosen this also. In each basket, you are putting only 3 fruits. That is also of one kind. Let's say, then this, for 12 apples, you will be needing 4 baskets. In each basket, there are 3, means you will be needing 4 baskets. And for 18, you will be needing 6 baskets. Right? So, think like, even in this case, in each basket, there are equal number of fruits. That is 3 in each of them. And there is only one type of fruit in each basket. But the problem is that you required more number of baskets. Why? Because you did not put the largest number of fruits in the basket. So you cannot use any other number other than 6. If you try doing so, what will happen is they won't be evenly divided. So one or two fruits will always be left out. So in order to include everyone in a group equally, HCF is used. So that is the purpose of HCF. So let's move on to another question. All right, we have another question similar to the previous one. So it goes like this. There are 36 English, 60 Hindi and 84 science teachers. They are to be seated in rooms so that each room has the same number of teachers and one subject per room, and only one subject per room. Find the minimum number of rooms required. So you have these many teachers from English, Hindi and science. So you are dividing the teachers and keeping them into rooms such that in each room there must be equal number of teachers. Also, in each room there must be teachers from only one subject. So similar to the previous one, where instead of in these subjects we had apples and oranges and baskets for rooms. Okay, but in this case what they are asking is how many, find the minimum number of rooms required. Okay, so you might get carried away by this word minimum. So when it is HCF, it is maximum, right? So why does the minimum here is that when you put maximum number of, when you divide the group of teachers into equal subgroups in such a way that you try to put in maximum number of teachers in each room, then minimum number of rooms will be required, right? So here, find the minimum number of rooms means, yes, we are supposed to find the number of rooms required, but we'll have to find the HCF of these 3 numbers. Means the more you put teachers in a room, the less number of rooms required. So ultimately it's like dividing these numbers by the biggest number, which is HCF. So HCF of 36, 60 and 84. The answer, I know it is 12. For you, let me do it for you. Prime factorize this 36. So 36, one of the factors of 36 is 6 into 6. So 6 is 2 times 3, this is also 2 times 3. So 36 can be written as 2 square into 3 square. Similarly, 60, 30 into 2, or let's say 15 into 4 is also 60. 15 into 4. So 3 5s are 15, 2 square. So this is 3 into 5 into 2 square. 3 5s are 15, 15 4s are 60. Okay. Now 84. 84 is 12 into 7. So 12 is 2 is a 4, 4 3 is a 12. Okay. 12 is 2 square into 3 is 12 into 7. So this is how you can prime factorize the numbers. First, you use one of the factors that you know, and then further break it down into prime numbers. So HCF means the product of the product of the smallest powers of each common prime factor involved in the numbers. So what are the common prime numbers? 2 and 3. You see 2 here, 2 here and 2 here, and 3 in all threes, right? So 2 and 3 are there in all the factorizations. So what is the least power of 2? Here 2's power is 2, 2's power is 2 and 2's power is 2. So least is 2 only. So its product is with 3. So least power of 3 is, although 3 is common, the least is 1. This when you multiply, the answer is 12. So this means in each room there must be 12 teachers. So how many rooms will be required? For English, I'm writing it in short. 36 divided by 12, it is 3. What about Hindi? Hindi, if you divide 60 by 12, it is 5. And science, you have 84 divided by 12, which is 7. So altogether you'll be needing 5 plus 7 is 12, 12 plus 3 is 15. I don't have a space here, so I'm writing it here. So you'll be requiring 15 rooms. This is the best that you can do in this situation, where you had to divide teachers into groups such that each uh, group must be the number of teachers in each group must be equal, as well as they must come from only one subject. So keeping those things into consideration, this is the best that you can do. So if you use any other number less than 12, that is a factor which divides all three, that way also you can divide the teachers into rooms, and that way also you'll see that all of them are equal. In each room there are equal number of teachers, as well as they are from one subject, but you'll be requiring more rooms. Okay, this is the best that you can do. If you think of any number bigger than 12, then you see it will not divide this perfectly, or it may divide these two perfectly, it won't divide 84. So that's how HCF comes into play. Okay, now let's move on to another question. I hope you understood this one. So we have this third question, and this one's a little different, although the answer is easy. The solution is easy. There are 24 chocolates and 36 candies. They are to be packed into identical boxes so that each box has the same number of chocolates and the same number of candies. What is the maximum number of boxes that can be made? So, what makes it a little confusing is that each box has the same number of chocolates and the same number of candies. So, here the answer is HCF of 24 and 36. Okay. But the answer that you get means something else. HCF is 12. So, what does this mean is the maximum number of boxes that can be made is 12. In this case, in each box there will be both chocolates and candies. In the previous cases, when you divided into groups, like divided teachers or the fruits, in each basket or in each room, there should be only one type of fruit, or only teachers from one subject. But here in each box there must be um, both candies and chocolates, equal number of candies and equal number of chocolates. So that is the thing we must keep in mind. So 12 means number of boxes. This is the maximum number of boxes. So that means, so this is your answer. It's done here. But further, what we can understand is in each box how many chocolates and how many candies will be there. If you divide 12 by 24, so in each box there will be 2 chocolates, and if you divide 36 by 12, there will be 3 candies. Altogether, there will be 5 sweets, 2 chocolates, and 3 candies. Similarly, there will be 2 chocolates and 3 candies. Likewise, there will be 12 boxes. So, understand the question and the solution. I think it will open up your brain. Okay, let's do another type of question from HCF only. So I have given this um, question the heading, the HCF remainder trap. So this is another type of question which comes from HCF, and this particular type we have seen in CBSE board exams quite many times. So let's understand this. Find the largest number that divides 70 and 125, leaving remainders 5 and 8 respectively. So you need to find the largest number which divides both of them uh, and leaves remainder 5 when you divide 70, and it leaves remainder 8 when you divide 125. The same number. So answer is, how you should do, you first subtract the remainders. Okay. So when you subtract 5 from 70, it is 65. That's what it says, right? If you divide this 70 by that number, the remainder is 5. And when you divide 125 by that number, uh, the remainder is 8. So let's subtract the remainder. It is 117. It means This 65 and 717 is divisible by that number. Whichever number is it, um, it divides these two numbers. But if 65 is 5 more, that is, if this is 70, then dividing 70, it will give 5 remainder. And if 170 is 8 more, that is 125, then dividing 125 by that number will give 8 as a remainder. So let us find the HCF of these two numbers. So 65 can be written as 5 into 13 is 65, and 117. So it is this 3 into 3 into 13. All right. So HCF is the highest common factor, which is the common factor here is 13 only. So this is 13. So 13 is the number, biggest number or the largest number that divides 70 and leaves remainder 5, and 125 and gives remainder 8. So by the way, I was trying to show you this. If you divide 117 by, when you prime factorize 117, a number like this, well, many of you might know which number divides this. For the ones who doesn't know, the trick is that if it is an even number, you start with 2. You are prime factorizing the number, so 2 is the smallest prime number as well as an even prime number. So if it is an even number, the last digit is even, you start with 2. If the digit is 0 or 5, let's say 5, divide by 5 directly. And sometimes it's, if the last digit is 5, 3 also divides that number. But if it is 5, you can go with 5. But other than those two numbers, how will you verify whether this is divisible by 3? Do this. You add the digits. If the sum of the digits, let's look here, 7 plus 1 is 8, 8 plus 1 is 9. So 9 is divisible by 3, means 3 divides this. So another trick is that the sum is 9. It means 9 also divides this number. So 9 is not a prime number, so we are going with something else. We're going with 3 only, since 3 divides 9. So 3 is a 9, 9 is 27, 3 ones are 3, and 3 threes are 9. Here also count 9, 10, 11, 12. So 12 is divisible by 3. So the LCM is, not LCM, the prime factorization of 117 is 3 times 3 times 13. So this is how you prime factorize. So I hope you understood. These are the different types of HCF word problems that you may see in your boards. This is it. So let's move on to LCM now. Now we will discuss about LCM word problems. So even for this one, we have some points to remember, the keywords that will help us recognize the question and solve them accordingly, just like the HCF. So here, please note this down. Use LCM when you see minimum, smallest, least. When you see these kind of words, when you see these words in the question, or something that happens together again, like which repeats, or traffic light problems, bells ringing, bells, let's say alarms ringing, or racing around a track, racing around a like closed track or a circular track, Moreover, it's finding the first meeting point. So this is the key part. Okay. So when we are finding LCM of two or three or two or more numbers, we are finding the first meeting point. So what does that mean? It means, for example, let's talk about the multiples of 2 and 3. So this one is the multiple of 2, multiples of 2. Let's say 2, 4, 6, 8, 10, 12, 14, 16, and so on. It will go on. And here multiples of 3, 3, 6, 9, 12, 15, 18, 21, and on. Okay. So what are the common multiples you see till here? So this one is a common multiple. This is a common multiple, as well as 18. Yes, 18 comes after 16, so this is also a common multiple. So out of these three common multiples, which one is the least? 6. In fact, there are so many other common multiples that come after 18 also, but the least common multiple is 6. So this is our LCM. So that's what that's what it was written here. Moreover, it's the first meeting point. Let's say one person moves slowly, another moves quickly in a circular track, and they leave together. So one who is quick will obviously bypass the slower fellow, but after some time he or she will meet the one who is moving slowly. So if it continues, then that person will not just meet, he'll cross that person and again meet after some time. But we are concerned about when will he first meet again after both of them leave. So that is the point here. So we have plenty of questions to solidify our understanding. Let's begin solving the questions. Here comes our first question from LCM Word Problems. A red light flashes every 4 seconds and blue light flashes every 6 seconds. If they flash together now, after how many seconds will they flash together after? Again. So if you understand the question, then this is a cycle repeating and it is happening together. So, if you recall the points to remember from LCM, then this is an LCM word problem. So you'll have to find the LCM of 6 and 4. So LCM of 6 and 4 is 12. So therefore the light will both of them will flash together after 12 seconds. After 12 seconds from now. Because now both of them are flashing together, right? So I hope you understood the question. Okay, you may understand this way. This is the starting point of red light. This is the starting point of blue light. So red light flashes after 4 seconds. First 4 seconds, and then it will flash at 8 seconds. Right, the multiples of 4. Then it will flash at 12 seconds, and 16. While blue light, if both of them flash together, blue light, the next time blue light is going to flash at 6 seconds. Next it's going to flash after 12 seconds. Next it will flash after 18 seconds. So here you see that both of them are flashing after 12 seconds from now. So this is the first meeting point. Hence the answer is given by LCM of 6 and 4. So I hope you understood. So this is, consider this is your multiples of 4 and this is multiples of 6. So that's how we got the answer. So let's move on to another question. So we have a question here. The traffic lights at three different road crossings change after every 24 seconds, 40 seconds and 30 seconds respectively. If they change simultaneously at 7 a.m., at what time will they change next together? So you see here the word traffic lights next together, and it's an event that will happen again, a repetitive case, a cycle. So considering the keywords, this is also a word problem from LCM. So what do we need to do is find the LCM of the three numbers. LCM of 24, 40 and 30. So you prime factorize 24. 24 is 12 into 2. So 12 I can write as 2 square into 3. This is 12 into 2 is 24. So in short I can write 2 cube into 3. 8 into 3 is 24. So 40, 8 into 5 is 40, and 30 is, it's 6 5s are 30, and 6 can be written as 2 into 3 into 5. So LCM of three numbers is that it's the product of the highest powers of each prime factor involved. What are the prime factors here? 2, 3 and 5. Okay. What is the highest power of 2? Highest power of 3 is 1, and highest power of 5 is also 1. So it is the product of the highest powers of each prime factor involved in the numbers. So if you multiply these numbers, this is 8, 3 5 is 15, so 8 into 15 is 120. So 120 is the LCM of 24, 40 and 30. Next, what does this mean? This means that the three traffic lights at three different road crossings will change together after 120 seconds. Okay. First, they change together at 7 a.m. After this, so after 120 seconds, it will change. So 120 seconds means how many minutes? You convert it into minutes. So if it is a huge number, you can convert it into hours also. Okay. So this one will convert it into minutes. So if you convert into a minute, you'll have to divide by 60. And look at the thing. Okay. You're finding the LCM of these three numbers, and these three numbers, the unit of these three numbers is seconds. Each one is a second. So the answer that you get is also in seconds. So that is why it is 120 seconds. So when you divide by 60, it is 2 minutes. 2 minutes. So the light will change the three different lights at three different road crossings will change together at 7:02 a.m. First they changed at together at 7. Now after 2 minutes all three will change together. So this is the answer. uh, you can have alarms ringing at 2 or 3 different timings. So they'll give you the exact time. They'll give you a time at which 3 alarm rang or beeped together. Now when will they beep again? So that kind of question will be similar to this. So I hope you understood. Let's move on to another question. Okay, let us look at this question, and I've given the heading LCM remainder trap. Just what we did for HCF remainder trap. Similar to that, the question says find the smallest number which is divided by 6, 15 and 18, leaves a remainder of 5 in each case. So if you see this kind of question, the numbers can change, but this is not uh, finding HCF, but this is from LCM. So that's why I've given this heading. Now you'll have to find that smallest number which is which when divided by these three numbers will leave the remainder 5. Okay, the solution is you first find the LCM of these 6, 15 and 18. So LCM of 6, 15 and 18 is 6 is 2 into 3, 15 is 3 into 5, and 18 is 6 3s are 18. Okay, 2 into 3 square. So answer is it is the yes product of the highest powers of each prime factor involved. So 2 is there, highest power of 2 is 1, highest power of 3 is 2, and highest power of 5 is 1. So what is the answer? It's 3 3s are 9, 2 5s are 10. So answer is 90. So 90 is the LCM of 6, 15 and 18. But this is not the answer. The final answer is next step you'll have to do. Next step is you add this remainder with 5. 90 plus 5. 95. So the answer is this 95 is your answer. This is how you should solve this question. Okay. So now you may check that if you divide 95 by 6, your remainder is 5. If you divide 95 by 15, again your remainder is 5. And if you divide 95 by 18, the remainder is still 5. Okay. So these are the different types of question that you might see in your boards from HCF and LCM. So we have completed every type. I hope you understood, and we'll see in the next video with another interesting topic. So until then, study hard and catch you later.